all right. It's about time. Like 2 minutes to go. I'm so excited to have us on this live session. Can drop a reaction, can drop a chat to express yourself, as we jump into the session for today. Uh, Sorry about that. I'm wondering, should okay. Um, Trying to switch. It's almost time. 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 Okay. All right. Hello, everyone. I'm excited to have us all on the call. So, all right. So, I want to implore us to drop our comment, right? Uh, you can just probably tell us your name. You can just drop your name and where are you dialing in from, right? Where are you dialing in from, and what are your expectations for this session, right? I believe you probably would have gone through the post that was made for prior to this session, right? You have gone through what we want to like look into today, more like the breakdown of what we are looking into. If you have gotten any hints from there, uh, I'm excited to be on this call with you guys. So I believe we are all here to learn. Right? I'm also here to learn with you guys. So I'm also excited. So we can get to it like in no time. Let's just give room for other people to join. Let's say 5 more minutes. And while we wait, please you can drop your name, where you are dialing in from, right? And probably your expectations from this session today. Okay. Okay. Let's wait like 4 more minutes. Yeah. We'll get started soon, right? We'll get started soon. Let's wait like 3 more minutes. Okay. We have Adele Adepoju joining from Lagos. It's good to have you on the session. Okay, 2 more minutes and we're gonna get started. 2 more minutes. If you're not subscribed to this channel yet, you can do well to kind of subscribe. Uh, Click on the subscribe button and the notification bell to get notifications whenever sessions like this going to happen, or probably a video is being dropped on the channel. You can always get notified. We have another person, David from Lagos. Interesting. We have another person, Temitoko from Lagos, Nigeria. Yeah, excited. I'm excited to meet you all. We're gonna start in 1 minute. 1 more minute. 1 more minute. Uh, I think everybody else is gonna join us in between, right? We are supposed to start by 3, but just to give like a few minutes for people to join us. 1 more minute, then we start. 1 more minute, then we start. Oh, interesting. Interesting. I can see Temitope Giwa from Lagos. Yeah, all right. I believe our expectations are going to be met today. All right, it's almost time. Almost time. Uh, we have Lawa Kausara joining from Kano. Interesting. Interesting. I'm so excited to meet you all. Uh, almost time. Almost time. Almost time, and we are going to be live. Okay. All right. Almost time. All right. So let's get started. Let's get started. I believe at this point in time, let me just switch my screen so I can just see what I'm doing, right? So let me see. Let me see whether. Okay. So I believe you should be seeing like a. Interesting. Okay. So you should be seeing my notebook or something, right? At the moment, you should be seeing my notebook. Uh, just a sec. I believe you should be seeing my notebook by now. So just to give like a background to what we're going to be learning today, right? So the data is about an e-commerce data set, right? They deal with selling products to customers. They're based in UK, right? And the focus is more to wholesalers, right? The focus of the business is more to wholesalers. So, okay, great. So the focus is more to wholesale, as I said earlier. And so just to give and I need to just mute this thing, right? And just give me a second. Give me a sec, please. Okay, I think it's fine, sure. So now, all right. So to give more of a background, I said it's e-commerce business, right? And the target is more like wholesalers. If you look into here, I've already provided like the schema of the data. We have what we call invoice number. And invoice number in this context is more like, let's call it order number. That is the unique identifier for the order that the customer actually wants to purchase in this case, right? And this invoice number can be attached to different products, right? So let's take it to a typical scenario that we'll probably relate to. Let's say I enter a Just right? Or let's say Jumia. Uh, I get a couple of products. When I select the products, I can select whether I just need one of it or a couple of it, maybe five or six in terms of quantity, right? Then I can select another product and select everything into a cart, then pay for those set of products. So I can get like six products. Those six products, them, right? And in Jumia database, right, where you're going to store your information, there's going to be something like invoice number. So there's going to be a number attached to that particular order, which might contain several products, right? And those products, there will be a quantity attached to them. So it might be just one quantity for a particular product that you purchase, can be six, can be 10, right? So this what we call this stock code that is here is more like the the product ID. So if I get an iPhone 14 Pro Max, let's say 256 gig of storage, that product can have an ID called 123. So that ID is the unique identifier for that particular product, right? And there's a description column which gives a description about the product itself, right? So because stock code in this case is just like a number or ID, the description is now what tells what kind of product it is. Then there's what we call quantity, which tells, okay, for this particular product that was purchased in this order, this is the number of units of that particular product that was purchased. Then this invoice date is more like the dates associated to that particular order. Then we have unit price. Unit price in this context is saying that this is the price per unit for this particular product. So let's say iPhone 14 Pro Max 256 gig is 1 million naira for one of it. So that's the unit price for that particular product. If I purchase six, so it means I'm going to be paying 1 million naira times six. Are you with me? So that is that. Then customer ID information is the ID of a particular customer. So my name is Abiodun Soni, right? And on Jumia database, I'll probably have an ID, right? Let's say the ID is ABC. Now we can have several Abiodun Sonis, right? But your customer ID is going to be different because of the information, the way they store their information. So even though another person that pays application goes on to Gmail platform, it's going to have a different ID. So that is why ID is important in storing information, because a particular information can have the same kind of naming, but the ID will be different to uniquely identify that this particular thing is different from this, right? Then country, the country from which the order was placed. Remember, it's an e-commerce business. So we're going to be talking about business question. There are some business questions that's been curated for this particular data set, and they are being segmented properly. We have customer segmentation, product performance analysis, uh, we have churn prediction, sales trend analysis, customer retention, and lifetime value. So we're going to get into it one after the other. All right, so let's go. So what I did is that I in the previous post I already made available the data set for this particular session. And the reason I made that post is that people can get to download that data set, and probably they want to follow along as we're doing this, right? So that's why I made that post so that people can have access to that data. So I downloaded the data as a CSV on my local, right? Then I want to use Python to do for this demonstration, but I'm going to be writing SQL. So it's SQL, not Python. So I'm just using Jupyter Notebook as the IDE to demonstrate this instead of having to like open a particular GUI for a particular SQL database like pgadmin or SSMS or something, right? So what I did is that I imported a pandas library to load the data as pandas data frame, and that's what I did here, right? I checked the shape of the data. We have about 541 over 541,000 records with 8 columns. So when I loaded it, this is the first 5 records in the data. So we have invoice number, this, but it looks like the stock code, more like the ID of the product, the description, the quantity, right? The dates of the invoice, the unit price, that is price per quantity, the customer that made that particular invoice, the country the order was purchased from. So so what I did is that I also converted this invoice date to like a timestamp, right? Which might not necessarily be necessary for this. But then you just have to do that. You might probably have to go and convert it later or something. So using SQL Alchemy engine, I loaded the data into my Postgres on my local. So I have a Postgres engine running on my local. I loaded the data there, and this is the command I used to load the data into my environment. If you want to make use of SQLite as an engine to query the data on the pandas data frame directly, you can use this library, right? But I don't want to use that, right? So now let's start with the first business questions without wasting much time. Now, customer segmentation. We already looked at the preview of the data itself, right? So we have uh, invoice number, as I said, uniquely identify the invoice, stock code, and etc. etc. So now let's get into it again. Now, customer segmentation. The question here is that what is the breakdown of customer purchasing behavior in terms of total revenue generated and total orders placed? How can we segment customers into different tiers based on spending? Now, if you are in an organizational setting, right, this question might be very, very specific, right? And we're going to go into that to like, okay, how can this question actually come if they're actually asking you in an organization, right? So now, I say, what's the breakdown of customer purchasing behavior in terms of total revenue generated and total orders placed? If I ask this question, so you're more like, okay, you want to analyze for each of the customers, what's the revenue that we have generated on those customers, what's the number of orders that these customers has placed, right, and the likes. So and you might want to also break this down into months, right? Because if I want to, look at the behavior. If I want to look at the behavior, I can't just look at the overall purchase for a particular customer. A customer might have started doing a purchase for like 2010, right? And a customer might just started doing purchases around maybe 2 years ago or something like that. So you cannot compare what the person has purchased over maybe 12 or 14 years compared to someone that just started doing a purchase 2 years ago. So I want to streamline that particular business question a little bit. So now we have this, right? This question. If I want to kind of know, okay, for the entire customer base and for the entire transaction base, right, across the years, I'm going to write an SQL query that looks like this. So what I'm trying to do is that, okay, I said select customer ID, then I'm doing a count, distinct count of invoice number. Remember, because of the way the data is, the invoice is broken down per product. So the invoice number is repeated. So if you look at this, because like this invoice number is the same thing as this, is the same thing as this, is the same thing as this, and like that. And the reason is that because there are different products that are being purchased in this same order, right? So this is a product for this, it as part of this invoice is another product. So it's being broken down at product level. So if I'm doing my count to know the number of orders, I have to do a distinct count of invoice number. So that will give me, okay, how many times have this particular customer generated an order in, from the business, right? Then in terms of revenue, that is how much of this person spends on the business. We have what we call unit price in the data, we have what we call quantity. Now, if I purchase 6 products, the amount I'm going to pay for that 6 products is 6 times how much they are selling one of those products. So if the product is 1,000, if I purchase 6 of it, that will be 6 times 1,000. That's why we are having this unit price times quantity. So by the time I sum that, I'll be able to get the amount of money this customer have spent. Now, I'm picking that from my data that I already saved. Remember, I already saved this into my local Postgres server. The name of the table is this. I've saved it inside the schema. The database name is part of this engine that I created here using SQL Alchemy. So that's why I'm doing the from this. So this is the name of the table, this is the schema I'm picking it from. So now I'm saying group by one. Group by one means that I'm grouping by the first column here, which is customer ID. So it means for each of the customer, I want to know the number of orders, right? And I want to know the amount that they have spent to purchase something from the business, right? Then finally, I'm doing an order by. So this order by, I'm saying that, okay, I want to do order by 3 in descending order, order by 2 in descending order. That is, you should first start from the revenue. So start with the customer with the highest revenue, then to the customer with, if there's any customer with, or if there are 2 customers with the same revenue, then consider the number of orders in this case. So that's what I'm doing order by 3 in descending order, which is the revenue in this case, and order by 2 in descending order, which is number of orders. And if I run this, I get this result. I just check the head. The head is going to give me like first 5 records. So let me rerun this again. And no, I have to rerun it from here. Let me create the engine. Let me import the library, then create the engine. I have to put my password. All right, so I believe that should have run. So I've already created this query. So let me run this to query. Oh, PD is not. I have to import the library PD. Let me go back here. So then run this query again. Then let me see the first 10 records entered. So now you can see that we have customer ID with ID 14646. Don't mind this point zero, it's not supposed to be there. And the revenue is about 279,000. That's the customer with the highest revenue, followed by this customer and the 10th customer, which is customer 15311, is about 59,000 in terms of revenue, right? That's interesting. Now, if you don't want to be biased, right? If you don't want to be biased, you might want to do something like this, right? Because because look at this person now. This person had 279 over 279,000 in terms of revenue, but the number of orders is 77, right? The number of orders is 77. And because someone that have been with the business over 20 years, or let's say 5 years or 10 years, compared to someone that is maybe 2 years ago, uh, uh, more often the person that has done 5 years with the business will have generated a lot of orders compared to someone that just started like 2 years ago or a year ago. So in terms of revenue and number of orders, the person with 5 years ago would have been up there, right? So let's do something like this. So let's do something like this. Uh, let's let's find the number of revenue generated per order. So how are we going to do that? We're going to calculate the revenue, the amount purchased or amount spent for all the orders for a particular customer, right? And also know the number of orders by that customer. Then we're not going to divide that revenue divided by the number of orders. That's going to give us, on the average, the amount a customer has spent per order on average. You understand me? So now we're going to try and do that now. So how do we do that? So I'm going to open up another cell to do that. Let's put it here. And we already calculated this. This is the number of orders, this is revenue. Then let's probably put another thing here and say sum of this, which is the revenue, divided by the number of orders, which is this. And let's alias it as revenue or average rev per order. Let's call it this. Let's now order by 4, that is the average revenue per order. So let's see how it's going to be different from this top 10 that we have here, right? So I'm going to create this query, then I'm going to run the query. Let me run the query. Let me give it order customer or average revenue per order or something like that. So, and show the first 10 records dot head. Let's see. All right. So look at this now. If you look at this now, look at this person, because this person had just one order. This person only had one order, and in a single order, this person generated like 6,200. Spent 6,200. This person that is stopping the chart here, even though this person is not here, right? Because I'm using average revenue per order. Look at this person. This person had made 26 order, was able to make to top 4. This person has generated 123,000 in order. But if I divided it by the number of orders this person has generated, it's about just 4,758. Look at this person here, 62 orders. This is the amount that will be spent on all the orders. If you divide it by 62, it means on average this person has spent 4,136 on a single order. So with this, you can then streamline your your KPI. And sometimes maybe business wants to give a threshold for the amount of orders in this case, because I don't probably something like I don't want to see it when someone that just made one order or something like that to to be a standard for judging this guy. Now let's say we have 30 days in a month, right? You have 30 days in a month. So you can say, okay, let's give like 15. Only show people that have done at least 15 orders to judge this scenario. So in order to do that, you have to apply having clause here. So we're going to say having after the go by. So we say having count of distinct invoice number, having count of distinct invoice number to be greater or equal to 15. It means that in this case, we are only considering customers that have generated at least 15 orders for this particular metric, which is average revenue per order. So in this case, this person that is one order will not be considered at all. This one that is four will not be out of it, out of the scope. So let's see who is going to make our top 10 in this case now. So let me run it and run this now. Nice. So we have these people that made our top 10. So let's see how many of these people are even up there. This customer ID 12415, 12415 might not be here because this one we are considering total revenue, so we cannot even compare it. So now, but this 1464677, this person is here. This person, in terms of total revenue, this person was number one. In terms of average, is number three. So you want to consider this as a fair bargain for this metric. This one gives more like a fair bargain. It does not consider the bias of someone that has been with the business for like 20 years compared to someone that is like 3 years ago, right? So you want to consider the quality of your order in this case. The quality of your order, and in this case, is depending on how much you spend on average on a single order, which is a fair deal in this case. All right. So going forward, there's another scenario said, how can we segment customers into different tiers based on spending? How can we segment customers into different tiers based on spending? So it means that based on how much customer has spent on your business, we want to now classify them or segment them as customers. So now in this case, you want to be very careful because you don't want to consider the entire lifetime from the inception of the business. In this case, I'm going to be biased, right? I'm going to be biased in your segmentation. So I think what you might want to do is to consider a certain month in the business. So you can say like previous months. So if you're in the current month, like you're in September now, you want to compare last month, which is August, right? August 2024, and say, okay, based on how much customer has spent, or you want to consider customer that has been in the business for the past 3 months. You can also do your classification based on that. So in our own scenario here, we can say consider just a month, which is probably last month, and then segment your customers in terms of revenue. That's what the question said. How much is spent? So you might want to check, okay, maybe on an average or maximum. You just check the range, right? Starting from zero, definitely. Maybe you can do zero to people that spend zero to 5,000, then 5,000 to like uh 20,000, 20,000 to like 50,000 in a month, then classify them like that. So now, what we're going to do is this. So in order to be able to properly manage this situation, we want to check the distribution of our customer purchase in this entire data so that we know how to now segment them. Okay, so the first thing we want to do is we want to check uh let's describe the distribution of the customer base for a particular month. So first I'm going to check the recent month in this data because this data does not have 2024 data. So let's have it. I think it's about 2010 to 2011 data that is here. So let's check the recent month. So let's quickly do that. I'm going to do that here. Let me come here and click another cell and say checking the recent invoice date in the data set. All right, uh hmm, so now let's put it. I'm going to like check the recent dates. That will be, say, select maximum. Select maximum of, let's cast the invoice date as date. Let me call it last invoice. Last invoice date. Okay, so cd.query or SQL query, then the engine, which is the connection. So let's see this. Okay, the recent date here is 9th of December 2011. So, okay, good. So we are going to consider the previous month for this recent date, which is November 2011 for our analysis. So, so let's check the pattern of purchase for the previous month. Pattern of purchase for previous month. So that would be, let's get a query for that. That would be like, okay, say for each of the customer, let's say for each of the customer to select customer ID, comma, we want to know the distribution of the purchase. So let's say let's sum, that will be unit price times quantity, unit price times quantity. Let me put it in quotes because of how this is going to appear. So let's put it revenue from our table, which is this. Let me just copy it, then group by one, right? Maybe on top of this, we can then, you know, do a description. You can describe. I think we can just use the describe method from Python instead of having to like write another max, mean, average, and stuff like that. So we can just use the describe function from Python. So you say pd.read, and also SQL, the query and the engine. Which is, then let's use the describe method to describe the data. Okay, so after we've gotten the revenue generated per customer, this is the description. So you can see here, we have a lot of records per customer here. So this is the revenue description here, and this is about the average here is about 2,000, because this 2 point something times 10 is per 3, which is 10 is per 3 is 1,000. So that's 2,000. The standard deviation, we need that. The minimum is minus 4,000. I'm not sure why we have negative value for quantity, or we might need to look into that. What's the maximum? The maximum is about 1 point something times 10 to the power 6. 10 to the power 6 is about 1 million, right? 1 million. So the highest purchase for a single customer in a month is over 1 million. That's about 1.4 million. So how do we now do our segmentation based on this? We can say then say creating. Oh, sorry, I'm so sorry. I thought I wanted to check for just the previous month. So let me just do that. Sorry, I lost track of that. So where I'm going to say where that's the invoice date where it is greater than say as 2011 11 10 is October is the 31st, and when the invoice date is now less than 1201 as date as date. So what I'm doing here is that I want to consider just November 2011. So I'm saying where the invoice date, let me call this as date, sorry, call this as date, okay, call this as date. So I'm saying that where the invoice date is above the last month in October 2011. So if it's above the last month in October 2011, so that takes us to what? To 1st of November 2011, right? And when the invoice date is now below the 1st of November. So what is below 1st of December 2011? That will be the last month in November, which is what we are trying to consider. So this is going to consider only the month of November, right? So I'm going to then run this. All right, so let's look at the description of the base now. So we have the highest there is about 329,000. This is 329,000. That's the highest a customer have done in a month, right? So how do you now do the classification? Let's just do creating the segmentation now. Since the highest is 329,000, so let's do it this way. Let's say first class, let's take class one. Let's take class one. Class O1 is customer that did between 0 to say 10,000. Then class 2 will be customer that did between 10,000 to say 50,000. Should I say 50,000? Let me say 20,000. Then class 3 will be 20,000, let's say 10,000 to 50,000. And let's say class 4 will be say 50,000 to 100. Then let's say class 5 will now be above 100,000. So we have 5 classes. So that's how we are going to classify those customers now. So that's this classification we're going to use. So before I proceed, I just want to quickly look at uh, uh, what's been our reaction so far based on what we've been doing. So you can drop your comments and drop your comments on the chat section. I would love to see all our comments there. Please let's drop our comments, please. Let's drop our comments. I would love to see all our comments so far. Let me see. Oh, shit. Okay. Okay, good. Okay, good. So I would like to see all our comments. What you have, what you think so far from this session. So now let's go ahead to like create the segmentation now. So let's go ahead and create segmentation now. I can see your chart, so let us just drop the chart in here. So now, uh, let me just copy this query. So creating the segmentation, I'm just going to edit it. So customer ID, revenue, blah blah blah. So we're considering this particular period, which is the the month before the recent month, which is November 2011. So on top of that, we're going to create our segmentation. So let me use CTE. If you're not familiar with CTE, it's very it's more like good practice to use CTE to write your query instead of using nested queries. It makes your code more readable. So let's call this customer revenue revenue 2011. So that's November 2011. Then put the entire query in bracket this way. On top of that, we now leverage that to do our segmentation. So select blah 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 from this table, right? You now say customer ID. So let me alias this as customer ID. So we now say customer ID, then let's go to the segmentation now. So case when revenue, sorry, let me close it up. Case when revenue, case when revenue, oh sorry, revenue is what are our classes again? Is less than or equal to 10,000. 10,000. Let's call it 10, say class O1. Let me put this case in a new line like this one here, and put it this way. Just kind of format the code very well. This one revenue is now greater than 10,000, and revenue is less or equal to 20,000. Then the second class O2, also when revenue is now greater than 20,000 and revenue is less or equal to 50,000, then they might have a specific class for this segmentation in your business. You can say bronze, silver, gold, titanium, like something like that, right? That also works. So when revenue is greater than 50,000 and revenue is less or equal to 100,000, then class, right? Then when revenue is greater than 100,000, then this one is class O4 rather. Class O4, then class O4 end at customer, let's call it customer class. Sorry, customer class. So Let's call this one customer segmentation. Call it customer segmentation. Then on top of it, we can now do the number of customers that falls in those segmentation. So let's say customer class, comma, count customer as number of customers from what? From we with customer underscore tag go by one, right? So let's now say order by two in count of those, maybe it's count of those in those segments. No, so arrange it by the segment. So let's put a else statement here. Say else because there will be some people that are probably okay. I think everything covers it here. Unless then it shouldn't supposed to be no. So this covers it. So let's now on the query. Let me call it customer class is equals to pd dot query or query underscore SQL rather your query and the engine. So then let's print customer class. Let's print it. So let's run it now. So this is what we have. Oh, interesting. Are you serious? Are you serious? Oh, oh, oh. So this is telling us that majority of the customers falls in the first class, which is less than 10,000 in a month, which in this case is month of November. So it means that all these ones, when we look at the summary, we have about 329. So it means that this one that we have 329 is more like an outlier and there's no customer ID attached to it. If you look at the majority of the distribution, so you can see 642, 352, 199, and the likes. The majority of the distribution is not even up to 1,000. So you might want to change this classification. So it means every other order or something is null because from the look of thing here, every other thing is null. So let's limit our orders, the value of the order between 0 to 1,000. So how do we do that now? How do we do that? How do we do that? Let me see. The minimum here is minus 295. 25% is 199. All right. So let's classify this thing again and call it 0 to 200. So this one be 0 to 200. Let's call this 200 to 300. 200 to 300. Then let's call this 300 to 100. 300. Then let's call this 500 to 800. Oh, let's go 500 to 800. 500, or let's go 500 to 1,000 instead. Then above 1,000. So let's put it this way. So we're going to change this also from here. So it's going to be 200, then greater than 200, less than equal to 300, greater than 300, less than equal to 500, then greater than 500, less than equal to 1,000, then this will be greater than 1,000. Yeah. So this should make more sense now. So if you run this now, what do we have? We have a proper classification now that makes more sense. So people that falls into the category whereby the revenue is less or equal to 200, we have about 429 customers that falls into that bucket, right? Then people that actually purchase over 1,000 in terms of revenue in the month of November 2010 or 2011 rather is about 222. So you might want to see, you might want to also see more like say the percentage. Okay, what's the percentage of this number to the entire population of the customers? You can also do that, right? That's also fine. All right. Yeah, we can get the Jupyter notebook after the session. I'm going to put it up in the GitHub repo and share the repo for us. So you can check, yeah, you can check the post. I'm going to post do a post and attach the GitHub repo where we can find Jupyter notebook. So ensure to subscribe so that I can get notified and probably be able to access it. So, it's going to be made public, so you'll be able to access it. All right, so that's about that. So let's go to the second phase here, which is product performance analysis. And this phase is very, very interesting. And the reason I like it is that it's what businesses use to for inventory management and stuff like that, in order to improve customer shopping experience. So in this case, they say which products are most frequently purchased together. So when you shop online, you get products and the like. So one want to see that, okay, what are those two products that when customer purchase product A, probably they are most likely to purchase product D, just like bread and butter, bread and sardine, all this kind of stuff, right? So I already created like a query for this before, and so that we don't also waste much time and we can cover as much as possible. So which products are most likely purchased together? So that's the first thing we're going to looking at. So let's think about it this way. Let's break it down. We have invoice, then we have products that are purchased in those invoices, right? So in a particular invoice, I might purchase 6 products. I might come again to do some buyings and buy some products in a particular, that will have another order itself or another invoice. Another customer will go in and do two stuff like that. So I want to know those products that they are commonly bought together. In order to achieve this, we are going to be doing something called self join. The way tables are being structured in terms of rows and columns. So you have your invoice, then you have your product, right? Then all of those relevant information. But what we need is just the invoice and the product, right? So now what we want to do is that we want to kind of place the tables side by side. Let me give you like an idea of what you're trying to do. So now let me create like a table. Let's say there's an invoice. We have what we call invoice number. So I will call invoice number. We have what we call stock code, which is more like the code for the product. So let's say we have invoice number 1234, 1234, 1234. Then we have another invoice, say 1111, 1111, 1111, 1111. Then there's some, let me put it as markdown. There's some 1234. So there are some products that are purchased together with this invoice. So let me call this let's say products ABC purchased products XYZ in this particular order, and then product VAT is purchased here. Then for this other invoice, product DET is purchased. Then here product VAT is purchased. Then product SUV and product XYZ. Now we want to do what are the products that are being purchased together. So this has to be done per invoice, right? Because this particular graph visualization. So if you guys this product is bought together with this product, and if you trace it down, you can see that this same product that is here, which is 22698, which is here, is also bought together with this product, which is 22699. Right? So you can connect the dot and say, okay, you can see that this 22699, which is here, is also kind of bought together with 22697. So you can kind of arrange the products so that those combinations can be in the same line and help customer shopping experience, right? So that is what this is going to help us do. So let's proceed to the next line. What are the top 10 products that are generated or that generate the highest revenue rather? What are the top 10 products that generate the highest revenue, and how does that change per country? So we want to know, okay, what are the top 10 products that have been purchased the most, and also how does this change per country? So there are two levels to this question. Let's answer the first one. The top 10 products that generate the highest revenue. So let's know what are those top 10 products that generate the highest revenue in the entire data set without being specific to each country. So let's take that first. So I'm gonna kind of copy this and put it here and say uh, top 10 products, top 10 products with the highest revenue, with the highest revenue. All right, so what we're gonna do is we're selecting from this table. We're using definitely stock code, which is the product. Let's use that product, and definitely sum the revenue, which is unit price times quantity. So that's unit price. You know that by now, right? Times quantity as revenue. That will give us like the total revenue per product. So this on clause is no longer needed. Go by one, that is go by the stock code, which is the product, and order by the revenue, which is the second column in this case. Since you're looking at top 10, so just limit it by 10. So this gives us the top 10 products with the highest revenue. So yeah, let's run it. Oh, interesting. So now we have this product 85123A, which is about which is giving us 2003 in terms of revenue, which is the one on top, and the 10th product is 20727. This is 1350 in terms of revenue. So those are top 10 products with the highest revenue. Now let's now look at how they differ by country. So I'm going to put country into this mix now. So let me copy this and say top 10 products with the highest revenue and how they differ per country and how they differ by country. So I'm going to use CPE to kind of break this down. So let's call this uh, country product revenue by country, product revenue by country as its product revenue by country like this. So uh yes, since you're putting country in the mix there, you have to put country here. So select country as country, then products, then oh sorry. This top 10 products with the highest revenue, this is supposed to be sum, not count. I was even looking at the result that is somehow. So let me go and again. So yeah, the products DOT with about 206,245. Then this product 164,000 and the likes. So these these are the top 10 products by revenue. So let's look at how they differ by country. So we are putting country in the mix here, and the products, then here some rather, and go by 1, 2, that is the country and the product. So when this is done, this is going to give us uh the total revenue generated by each product in each country. Now, we now want to know the top 10 in each country, right? So in order to do that, we need to rank the product revenue in each country. So in that case, we are going to use Windows function. So let's call it rank product revenue per country. Let's call it this as we now say select star from this guy, product revenue by country, which is what we have done on top there. Then do a rank. So say rank over, we are ranking the revenue. Let's say, sorry, rank it over partition by country because we want to rank it for each of the countries. So that was a partition by country. Then what is the order that we want to rank it? So order by the revenue in descending order. In descending order of the revenue. So it starts from the highest revenue. So let's call it rank product. So we are now going to select from this rank that we have done here. Then filter it where the rank prod is equal to 10. This is going to give us the products with ranking of 1 to 10, between 1 to 10 in each country. So let's order the result by country. Order by country, order by country, and by the rank prod. By our country and by the rank prod. Okay, I think this should work without any error. But syntax error, so there's something we are missing. Let me see. It says let me see from the top here. Okay, syntax error near ranked something. This one is supposed to be part though. Let me just correct this one, but it does not matter. But let's see where the error is. This is complaining from here 911. This is supposed to be something here. So let's okay. I didn't put from. So from. So let's run it again. Okay, what's the issue now? So group by is required. Goodbye. Goodbye is not actually required. I don't think I need to put this. Let me remove it. All right. So now this is not really showing the result very well, right? But then the idea is that you can see uh why is USA jumping ranking? Yeah, is USA jumping ranking? I can see from rank 3 jump to rank 7. I think some products have the same revenue. That's why it's jumping the rank here. So if you don't want this kind of situation, you can just use row number. You can just use row number instead. I think it's kind of jumping the ranking. So let's use row number in order to avoid that. So it means that using row number, it means that if a product have the same revenue, the ranking is going to be the ranking is going to be different. So let's say we have products A, B, and C having the same revenue. If they are at the first three, they're going to have one, two, three, right? So it's going to give them different ranking. So as the case may be, so let's use real number. So I use real number now. You can see that you don't have that issue. So you have 6, 7, 8, 9, 10, the way it's supposed to be. So that is that. So you can see from for each country the ranking of those products. So for country Australia, this is the product that is taken first, which is about 3,003 in terms of revenue. Then this followed by this product down the line. Then for USA, it's not printing everything. So we have about 378, 379 rows. You can see it here. So it's not showing the preview of everything. So you can if you want to see that, you can export it as CSV or something like view the results. But this is what we are looking for. All right, having said that, let's proceed. Let's proceed. So let me see. Uh, Somebody's talking about the class. I want to ensure that I'm not missing anything. Uh, yeah. Yeah, we're good to go. We're good to go. All right. So thank you guys. So now let's move to, I think the next thing should be the churn prediction. Yeah, the churn prediction. So this part is also very, very interesting because you want to understand how your customer dropped off stop being active on transacting on the platform. So how many customers have stopped purchasing from the platform over the last 6 months? Also, which customer demographics have the highest churn rates? So in this context, we want to know which customer have stopped transacting in the last 6 months. Oh, this is interesting. So how do we do this? So you might want to see, okay, who are those customers that have transacted before the last 6 months and they're not transacting in the last 6 months. So what I'm saying is this. So let's say we are considering uh we are considering 2024 as the timeline. Let's say we are considering 2024. It means that the last 6 months of 2024 is like we are in the we are close to the last quarter, we are in September. So let's say give or take September, August, July, June, May, April, right? Say April to that'll be April to September. So you want to know customers that have not been transacting from April to September, but the concept of churn is that you were doing something before, you were transacting before, but now you stopped. So you want to consider transacting in this period, but they have been transacting before this period. But in our own case, the recent transaction that we have is 20 2011 12. That is the recent invoice that we have is December 2011. So you can kind of do 6 months before 2011 before December 2011, 6 months before December 2011, that would be like June, no, July to December 2011. Then before that June, or sorry, July 2011, before that July 2011, who are those set of customers that have been transacting, and were they not transacting, or if they were not transacting between July to December 2011, those are the set of customers that we are considering as churned in the last 6 months. All right, so uh, this is how we're going to go about this. So we are considering we are considering customers that haven't transacted in the last in, transacted between, that will be between June 2011 and and December 2011. So let me change this to this, so that have stopped transacting. Let me put it that way. That have stopped transacting. So that's the correct statement to use. We are considering customers that have stopped transacting between June 2011 to December 2011. So we're going to say, first of all, we want to identify customers that have been transacting before this time. So let me create a query. So say, let me use CTE customers, or let me say transacting customers before 2011-06, that is June 2011, as select uh select let's put it this way, select customer ID. Let me alias it as customer ID from, let me call the table, this is the name of the table. From this table, where then we want to consider before June 2011, where as invoice date is less than, as that's 2011 0601 as date. So when the invoice date is, yeah, less than June 2011. So those customers have been transacting before that time. You only consider those customers, and definitely customer ID is not null. You don't want to pick where the customer ID is null, because you have seen this data set that customer ID can be null. So go by customer. You just want to select those unique customers. That's why we are grouping this. So this is going to give you those set of customers that were transacting between this before June 2011. Okay, now what we are now going to do is, ideally you want to say, okay, these customers, you now say not in or something like that. You don't want to use not in. You want to use a join to pick those that are not transacting. So what we are going to do is, we are now going to select customers that were transacting after this period. Or we say customers that are transacting between the time period that we want to consider. Let's call it TX customer in churn period as this. So I would this one I'll not be considering when it's greater than uh no, this one has to be July. This one has to be July because you said so this has to be July 2011. So that's 6 month period. So July, so that would be greater than 30th of June, and let me put it in a brace. Let me put it in a brace like this, and and the invoice date is less than 2012 01 that is before the next year, which is 2012 January 1st. So that will be considering like July to December, right? So we're not considering those customers that are transacting within the term period. So the idea is that we now want to take those guys that are here but are not here. Those that are transacting before June, sorry, before July, let me call it '07. Transacting before July but are not transacting in the churn period. So we are now going to do this, say select blah 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 from, let's do a left join from this, let's call it A1, and do left join. So the concept of left join is very, that's why I'm doing this. Also implementing the concept of left join. Left join the churn period on what? On A1 dot customer ID equals to A2 dot customer ID. Now we are now choosing, because a left join does everything from the left compared to what is matching on the right. Now what is on the left? Those guys that have transacted before, right? Out of those ones that are transacting before, we now select those ones that are not transacting after. So those customers that are here, that are doing transaction before, that are now no longer doing in the churn period. So all those ones that are common between these two are those guys that are still transacting. But the ones that are not common are those guys that have churned. So we now put a where clause and say where A1 is our customer transacting before, where A1 dot, sorry, where A2 dot customer ID is null. What I'm trying to say is that because if there is no match between this and this, it means that the customer ID in the churn period will be null because it does not exist there. Do you understand? So those customer that does not exist in the churn table. So when the customer ID is null, it means that that particular customer in this before the churn period are not transacting in the churn period. That will give us the list of customers that are not transacting in the churn period. So we can just see them or we can just count them. So if we do a count, I can say select count of what? A1 dot customer ID, because I want to count those customers in before churning, but they are not, that they have not churned, they have not stopped transacting. So I'll call it as churned customers. So if I run this now, let me run it. Let me put let me just copy this. I don't want to be typing again. So I'm running. So we have 977 customers that have stopped transacting So they have been doing transaction before, but now within the last 6 months, they have not transacted. Now, let me do something. Let me get the numbers of those that were transacting before and now compare it to this 977. So why is this thing behaving like this? So those that are transacting before, let me transacting before. So I'll just say select blah 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 count this. Let me call it trend customer trend. So yes customers before. Let me call it yes customers before. And let me run this one again so that you can see this one now going to be together we're transacting before, right? So let me run this. So you can see the numbers. We have 3,002 customers. Yeah, 3,002. They were transacting before, but now out of this 3,002, almost 1,000, that is one third, almost one third of those customers have stopped transacting, which is a very large number. It's a big problem for the business. So the business can then do some uh, customized campaigns to win those customers back, right? They might want to look into their transaction behavior and look and figure out a customized campaign to win them back to the business. So I think that is that. So also there's another thing to it here. They say which customer demographics have the highest churn rates. Which customer demographics have the highest churn rates? So now out of these churn customers here now, we want to know the the demography of those customers. Let's in this data set, we are only going to be streamlined to just the country where the order is placed from. So we want to know which country has the most churn customers in that context. So let me kind of modify this comment here. Uh, let me say, or let me just kind of like put everything together into this one script. So you want to know the number of people that are transacting before and number of people that are not. So let's just put it together here as a one single script. So count this as transacting customer before. That will be count of A1 dot customer ID. So I have to take this one away from here, right? But I'm going to do a case when here. So case when A2 dot customer ID is null. That will be for the customer. Sorry. Case when A2 dot customer ID is null, then this, and so that would be for the churn customer. This customer before then to do like the percentage now. So this is going to now be this divided by the number of customers that have been doing transaction before, then times 100 as 10%. I think this then I have to take this one out of here. Let me just comment it. I'm going to take this one out of here. Remember, I've commented this out. That's why this dash is here. So it's take note. Uh, okay, I know what I'm going to do. I'm going to cast it as float or something. That's what it's giving us there. Don't mind. Cast this count as float. I think SQL Server also have this kind of issue, right? So I think it should fix it now. So you can see about 32% of them are churned, which is a big problem. So I'm going to remove this part from here, so it's no longer needed. So the next thing is that demographic of those with the highest churn, right? Demography of those with the highest churn. Uh, demography of those with the highest churn. Demography of those with the highest churn. So in this case, we want to look at those guys that are churned and which country, which country, which country did they place the order from? Like which country are those customers from? So I think what we can do is that since you know the number of the those customers, and I think that country column kind of is being unique to each customer. So you can use that to check the demography, but let's just verify that that country is unique to each customer and we don't have a situation whereby a particular customer can place have placed order from different country. So let's check that real quick. Doesn't really matter. Okay, we can just go ahead and do what we're going to do is this. We're going to create a query and say find the country of each customer. This query is going to find the country of each customer. So let's say with customer country as select, let me say select country, country as country, then customer ID as customer ID from the table that we are picking from this table. I don't want to select null customer ID. So where customer ID is not null. Yes, definitely. Then go by the country and the customer. So we have the country that each customer belongs to. So on top of that, we want to identify the churned customers, of which we have been able to do that in here. So I'm just going to copy this code. Yeah, this code. Let me copy it from here to this place. Yeah, from here to this place. To this place. And put a comma here. Put it here. These are the these are the customers that are transacting before, and this is the customers that are transacting within a churn period, and to get those ones that have churned, right? That would be A1 dot customer ID from this. You have left the then definitely select where A2 dot customer ID is null. Then you have to do it like a join. Yeah. Then we have to do like a inner join with the customer demography. You want to add the country. So let's call it CC. Then join on A1 dot customer ID equals to A CC dot customer ID. Yeah, customer ID. So remember that we want to know the demography of those with the highest churn. So we are going to select the country, then count the customer ID. To be on the safer side, we can do a distance count here because we don't trust what's coming from here as churned customers. as churn customers. Then what are we missing? Let's do order by two, which is the number of customers that is churn. So they start from the highest from each country. So then we query the data. Our query, then the engine. There's a syntax error somewhere. I don't know where that is from. Let me check. From this. Okay, I'm putting a comma here, so there's not supposed to be a comma here. So let's run it again. Wait, column must appear in a group by. Oh, I didn't put a group by, sorry. So group by one. All right, let's do that again. So majority of the churn customer comes from the UK, right? And that's because I think I mentioned in earlier that the 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 business is based in the UK, so majority of the orders is going to come from the UK. So it's understandable that majority of the churn customers will come from the UK. But if you ignore the UK, you have France, Germany, 18 customers come from France, 16 come from Germany, and that's the demography here. So we have been able to answer that question. So now I'm going to save this quick at this point. Then another thing that we have at the moment is sales trend analysis and customer retention and lifetime value. For the sales trend analysis, we want to say, okay, what are the monthly sales trend over the last 2 years, and how do seasonal variations affect sales? And can you identify months with unusual spikes or dips in sales? So in this particular question, it means I want to identify the revenue that's been generated on a monthly basis, and you're considering the last 2 years, right? This data is more like 2 years, that's 2010 to 2011. So it's more like you don't have to filter anything. But if you're dealing with recent data that is being populated, uh, so it's only you want to consider between now and 2 years later. So that would be between maybe October 2022 and now, right? So let's say October. Is it October? Yeah, October. So now that is what this is going to look like. So I'm thinking that we should push this to this second part of this second episode for this series. So the second episode is going to happen the last Sunday, the fourth Sunday of this month. That's like on the 29th. Yeah, on the 29th. I'm going to communicate that to us, and definitely we're going to be updated. And please do well to uh, subscribe to the channel, click on the notification bell to be notified when similar content like this has been posted to the channel, right? So as I said earlier, I'm going to create a GitHub repo for this file, so and notify us on the YouTube post, so you can always get notified. And for this second part that has not been treated today, I will probably update this notebook, so you can even have the notebook, like the solution to this particular phase, on the GitHub repo, and you can go through it and kind of explore your own, right? And I'll more add more comments to the code so that you can probably also relate with it very well. And that's for this last two parts. For the previous ones, you can take time to go through the recording again and look at what we've done. So at this point, I'm just going to leave the session open to questions. So if you have questions, you can drop it in the chat so that we can treat them together. So let's have it. Let's have it. You can drop a question in the yeah. You can drop a question in the chat. I want to see it. So